Today, I'm going to be talking about the Ross-Littlewood paradox, a paradox that actually isn't even a paradox. So, to begin, the paradox. The paradox starts with an empty vase and an infinite supply of balls, and then an infinite number of steps performed of the following. 10 balls are added to the vase and 1 ball is subsequently removed, and this together is one whole step. Now, the steps occur from 30 seconds before noon. This all happens in the time span of 11:59 to 12. So the first step occurs 30 seconds before noon, then the second step occurs at 15 seconds before noon, and the third step occurs 7.5 seconds before noon, and etc. And you have to assume the steps do not take time at all. And so, the question is, after performing an infinite number of steps in an empty vase with an infinite number of balls, how many balls are actually left inside the vase at noon? So, in order to do this problem, we have to understand what a one-to-one correspondence is. So basically, a one-to-one correspondence is where you have an item, and that item, for all those items actually, you have a corresponding item, and you basically have 0 left over. So this is kind of like a division problem where you have 80 students and you have 80 chocolates, and you're basically giving each of them one, creating a one-to-one correspondence because each student has one chocolate. And so likewise here, we have 12 golf clubs, and so in order to have a one-to-one correspondence, you need 12 golf balls, just like right now. So, coming back to the paradox, what is the first solution? Well, the first solution is that the vase is full. Let me explain. The reasoning behind the first solution is that there is no one-to-one correspondence. Therefore, you are left with an infinite number of balls inside the infinitely big vase. This happens because you take out balls 10, 20, and 30. As you can see, this does not create a one-to-one correspondence because you still have 9 balls left over after each subsequent step. So this brings the equation 9 times infinity, because 9 times the infinite amount of steps is what you're getting. And since infinity is the largest number there is, the 9 times infinity should also be equivalent to infinity. And so, therefore, when the clock strikes noon or 12 p.m., the vase is full. The second solution, the vase is empty. Let me explain. Reasoning behind solution 2 is there is a one-to-one correspondence. Therefore, the vase is empty. This happens because for every 10 balls you add, you take out the balls 1, 2, 3, and 4. For example, you do 3 steps, so you take out balls number 1, 2, and 3. This creates a one-to-one correspondence. So if you do an infinite amount of steps, you're basically taking an infinite amount of balls. For example, for the 101 step, you're taking out ball number 101. That's basically what happens. And so, because of that, you get the vase being empty at noon. So, these are graphs related to this problem, or paradox, if you suppose. So, the graph on the left side shows the balls being added before noon. This is kind of an exponential graph, where you can see right here from the red going up that it exponentially increases until the clock strikes noon at 60 seconds right here. And there, and here the green dots show the time. So this is 11:59, 0 right here, and 60 seconds right after that, that would be 12. And the time also exponentially increases or halves, if you say this graph shows. And so the clock graph on the right shows the time halving each and every task. That's basically all it shows. So, what is the actual math behind this paradox? So, you have 10 times I, where I is the number, the ball number basically, minus 9 to 10 times I. So, N over here is your desired outcome. So, for example, if we're proving the ball for it being full, then we would use equation 1, because N will always be greater than I, because we're trying to get an infinite number of balls. So N over here would be replaced with infinity. Then, for each ball, you would remove 2 times that ball. So, for example, ball number 1, you would have I. So, let's replace I in this equation. 10 times 1 minus 9, which is 1, to ball number 10. So, 1 through 10 are put into the vase. Now, since we're using the first one, because infinity is always greater than I, then you remove ball number 2 times I. So in this case, ball number 2. And then if you go on to each subsequent step, you will see that this does not create a one-to-one correspondence. Now, what if we want to prove if the vase is empty? So, if the vase is empty, we use the second equation right over here, where I is always greater than N. Our desired outcome is 0 right here, and I will always be greater than 0, because you can't have a 0 ball. So, when I is greater than 0, then remove ball number N plus 1. So, let's plug in 1 to the equation again. So 10 times I minus 9 to 10 I, so 10 times 1 minus 9, which is 1 to 10. Now, we would remove ball number 1, because 0 plus 1, again the desired outcome here is 0, 0 plus 1, again would be removed. So ball number 1 would be removed, going back to the one-to-one correspondence I showed you before. So, in conclusion, is this even really a paradox? Well, technically, this can't be considered a paradox in the sense that there are no logical flaws in the solution's conclusions. Actually, depending on which balls you remove, you could actually come with different solutions than these two. So there is no logical flaw here. So technically, it can't be considered a paradox. You could maybe say or argue that the paradox, or the problem in this case, is not constrained enough to where we know if it's a paradox for sure or not. How does infinity affect the problem? Before, in a slide, I said 9 times infinity equals infinity. Well, we're trying to apply basic arithmetic skills here. 9 times a number should equal 9 times that number. For example, 9 times 2 should equal 18, or 2 nines. But in this case, we're trying to multiply 9 and infinity together. But infinity, theoretically, is the biggest number there is. And so that really doesn't make sense, right? How can you multiply 9 times the biggest number there ever is and get a bigger number than that? That wouldn't make sense, because infinity is always the biggest number. And so 9 times infinity has to equal infinity. And so basically, the basic arithmetic skills don't even apply to infinity. And so that's where this paradox really occurs. It's because infinity isn't like all the other numbers. So what's the actual answer? As I said before, these are only two solutions to this problem. These are the main solutions, actually. Depending on which balls you remove per step, you could actually get different solutions. So why is this interesting? This really shows us how math is a very special kind of subject, because not all the laws apply. What we've learned since like grade 1, we have learned that something times something equals something, right? Something times something equals 5 times this number, etc. And so here in this case, we see that that doesn't really apply anymore, because you can't apply basic arithmetic skills into a theory and expect to get the same result. And so here, it really astonishes the person, because the skills they've been learning up till now don't even apply. They just disappear. And so therefore, I conclude the Ross-Littlewood paradox, which is really not even a paradox, considering what a paradox means.